Good morning children, welcome back to EDUHUNT IIT Academy. In the previous lecture, we discussed Lewis dot structure and also formal charge. In this video, we are going to discuss different types of chemical bond. So what are the different types of chemical bond? Ionic bond or electrovalent bond, covalent bond, coordinate covalent bond or dative bond, fourth one hydrogen bond, fifth one metallic bond. Now we are going to discuss these different types of chemical bond. Let us discuss first ionic bond. What is ionic bond? Ionic bond is the electrostatic force between two oppositely charged ions. Oppositely charged means cation and anion. Cation having positive charge, anion negatively charged. So that means between these two oppositely charged ions known as ionic bond. So the force of attraction between two oppositely charged ions is known as ionic bond. In the formation of ionic bond, what happens? Complete transfer of valence electrons takes place from one atom to another atom, that is from donor to acceptor. So in the formation of ionic bond, electrons completely transfer from donor to acceptor. Donor forms cation and acceptor forms anion. Cation positively charged ion, anion negatively charged ion. So finally, what is ionic bond? Ionic bond is the electrostatic force between two oppositely charged ions, that is cation and anion. So in the formation of ionic bond, electrons completely transfer, valence electrons completely transfer from one atom to another atom, that is donor to acceptor. Donor forms cation, acceptor forms anion, and the bond between cation and anion is known as ionic bond. Let us discuss some examples. See, we know generally each and every atom looking for get octet configuration. That means looking to keep 8 electrons in the valence shell. Octet means 8 electrons. Each and every atom looking for stability. When an atom gets stability, if it has 8 electrons in the valence shell, then that will be stable. 8 electrons means that follows octet rule. Okay, so each and every atom looking for stability, that is to keep 8 electrons, try to keep 8 electrons in the valence shell. Okay, let us discuss formation of NaCl. Example, formation of NaCl, sodium chloride. See, in the formation of sodium chloride, what happened? We know sodium atomic number 11, electronic configuration 1s2, 2s2, 2p6, 3s1. Chlorine atomic number 17, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. See, in the sodium, in its valence shell, there is 1 electron. In the chlorine atom, in the valence shell, there is 7 electrons. See, observe sodium and chlorine. When sodium will get stability, that means when it get octet configuration. See, this is outermost shell. In the outermost shell, there is 1 electron present. In the inner shell, there are 8 electrons present. 8 electrons. Inner shell. If it lose one electron, then it will get octet configuration. In the valency shell 8 electrons, then that will be stable. Coming to the chlorine atom. In the chlorine atom, in the valency shell, how many electrons present? 2 plus 2 4, 4 plus 2 6, 6 plus 1 7. It need 1 electron to get octet configuration. That means to get stability. Okay, so then what happened? Sodium asked to chlorine, dear chlorine, I have 1 more electron than octet configuration. You need 1 electron to get octet configuration. That's why I will donate 1 electron and accept the electron. Then you can accept the electron and we both will form a bond. That is known as ionic bond. Then both will get stable. See, then sodium ready to lose 1 electron. So ready to lose 1 electron and forms cation. And chlorine accept this 1 electron and gets and forms Cl minus ion. And now Na plus and Cl minus combine to form NaCl as ionic compound. This is ionic compound. Got it? How an ionic bond is formed? See what happened in the formation of ionic NaCl. See, sodium atom has 11 electrons. In its sodium atom atomic number 11, in the valency shell 1 electron is there. In the chlorine atomic number 17, in the valency shell 7 electrons present. Sodium has 1 more electron than octet configuration, 8 electrons than octet configuration. Chlorine required 1 more electron to get octet. Already 7 electrons present. So it need 1 more electron to get octet configuration. That means to get stability. Okay. Then sodium asked to chlorine, dear chlorine, I will donate 1 electron. Please accept the electron. Both will form bond and both will get stable. See, then sodium ready to lose 1 electron and forms Na plus. Chlorine accept the 1 electron and forms chloride ion. And now Na plus and Cl minus combine to form NaCl as ionic compound. Got it? So here what happened? Complete transfer of electrons takes place from one atom to another atom. So here sodium is donor and Cl is acceptor. So donor forms cation, acceptor forms anion, and the bond between cation and anion known as ionic bond. Got it? So both will get octet configuration. Now chlorine get octet configuration, already 7 electrons. If it accept 1 electron, then Cl minus ion, 8 electrons in the valency shell. Sodium, after donating this electron, now sodium has 8 electrons in the valency shell. Now Na plus, so then Na stable or Na plus stable? Na plus stable. Cl stable or Cl minus stable? Cl minus. Chloride ion stable. So Na plus already 11 minus 1 10, then it reaches inert gas configuration, neon. Chloride, it reaches argon configuration. Cl 17 electrons and accept 1 more electron. 17 plus 1 18. 18 means argon, inert gas configuration. Generally inert gases are stable because they have octet configuration in the valency shell. So each and every atom looking for get stability. To get stability, trying to keep 8 electrons in the valency shell. For that, so in the formation of ionic bond, what happened? Electrons transfer from one atom to another atom. Donor to acceptor. Donor forms cation, acceptor forms anion. So both will get octet configuration. That means reaches inert gas configuration. So each and every atom try to get inert gas configuration. Inert gas configuration nothing but octet configuration. So if they get octet configuration, they will stable. Okay. Some more example. Formation of MgO. Second example, formation of MgO, magnesium oxide. One more example, ionic bond. See, in the formation of MgO, magnesium, atomic number 12, electronic configuration 1s2, 2s2, 2p6, 3s2. Oxygen atomic number 8, electronic configuration 1s2, 2s2, 2p4. See, observe this. In the magnesium atom, in the outermost shell, 2 electrons present. In the inner shell, 8 electrons. That means it has 2 more electrons than octet configuration. 2 more electrons. That means to get octet configuration, ready to donate. Ready to donate 2 electrons. See, oxygen, in the valence shell, how many electrons present? 2 plus 4, 6 electrons present. 2, 4, 5, 6. So to get octet configuration, it needs 2 electrons. Okay, so ready to accept 2 electrons. Oxygen ready to accept 2 electrons. Now magnesium ask to oxygen, dear oxygen, I'll donate 2 electrons. You can accept 2 electrons, both will form ions and will get stable and forms ionic bond. Okay, then magnesium transfer these 2 electrons, to oxygen. Then C, magnesium Mg2 plus 2 electrons. Here magnesium donor. Okay, it lose 2 electrons. Now oxygen accept the 2 electrons and forms O2 minus oxide ion. Now Mg2 plus O2 minus is gives rise to MgO, magnesium oxide. So Mg stable or Mg2 plus stable? Mg2 plus stable, because here inert gas, that means octet configuration is present. Okay, O stable or O2 minus stable? O2 minus stable. Okay, both will get neon configuration. Mg 12 minus 2, 10. 10 means neon configuration. 8 plus 2, 10 means neon configuration. Neon means inert gas. Inert gas generally stable because they have octet configuration except helium. Okay, so this is formation of MgO. So what happened in the formation of ionic bond? Complete transfer of electrons takes place. So magnesium here transfer the electrons to oxygen, 2 electrons. Then magnesium get octet configuration after donating electrons. Oxygen get octet configuration after receiving electrons from magnesium. So both will get octet configuration and become stable. Okay, so this is the formation of MgO. One more example, formation of Na2O, sodium oxide, Na2O. See, here how many sodium atoms are there? 2 sodium atoms. How many oxygen atoms? 1 oxygen atom. We know sodium atomic number 11, electronic configuration 1s2, 2s2, 2p6, 3s1. In the outermost shell, it has 1 electron. So to reach octet configuration, it is ready to donate electrons or ready to accept electrons? Ready to donate, ready to lose electron. Why? Because if it lose this electron, then get octet configuration. 2 plus 6, 8 electrons. Okay, chlorine now, oxygen electronic configuration 1s2, 2s2, 2p4, Oxygen has 6 electrons in the valency shell. To get octet configuration, to reach inert gas configuration, or to become stable, it requires 2 electrons to get octet, because 6 electrons present in the valency shell. Then what happened? Each sodium has one extra electron than octet configuration. So 2 sodiums present. So 2 sodium, one sodium donate 1 electron, and another sodium donate 1 electron to oxygen atom. So 2 sodium atoms donate 2 electrons to 1 oxygen atom. Now see, 2 sodium, 2 Na is gives rise to 2 Na plus 2 electrons. Now oxygen accepts 2 electrons and forms O2 minus, and finally 2 Na plus O2 minus is gives rise to Na2O. So this is ionic compound. Okay, so in this way ionic bond formation takes place. So generally ionic bond means a force of attraction, that is electrostatic force between two oppositely charged ions. They are cation and anion. So in the formation of ionic bond, what happened? One atom ready to lose electron, ready to donate electron, another atom ready to accept electron, known as acceptor. This is donor. So generally bond formed between donor and acceptor. So here complete transfer of electrons takes place from one atom to another atom. So to form ionic bond, one atom ready to donate electron and one atom ready to accept the electron, then only they can form ionic bond. Okay.